All right. Okay, so this is the midterm review. It's pretty simple. We only have 6 questions. What we'll do is like I'll give you guys a minute or so to read the questions by yourself, understand it on your own, and then I'll try to like explain the question conceptually. For the people who are not here and are like watching the video on YouTube, you can just skip over a minute, and then try to like if you have read the questions beforehand, you can just skip over the minute, or like you can just pause the video. So I'll just give you guys a minute to read the question. If you understand it, good. If you don't, I'll try to explain it conceptually, try to draw some like visual aid diagrams. So yeah, just give you 1 minute. Hopefully you guys were able to read the question yourself. I'm kind of like not giving you too much overtime because I'm trying to mimic how you would. Uh, I'm trying to mimic like in the exam you'll only have like a minute or so, like minute to 2 minutes to read the question and then solve it. So okay, if you weren't able to understand it, that's fine. I'm gonna explain it conceptually. So what the problem is even asking us? Let's begin with that. We are given a struct, right? So I like to draw boxes. So we're given a struct. Initially, this struct has 3 fields. So it has name. It's called driver name, but I'm using like short forms. So name, and then it has a pointer, which is to another struct called items. Uh, and then the third field is the item count. Let's call it count. Let's just call it count. So what the question is saying, you guys might have played the game Mario Kart, right? So once you're like, let's say you're on a track, right? This is you. In this track, you're able to pick up at max, you're able to pick up 3 power-ups as you like going along the game, right? So what the question is asking us is like you are the racer or you are the driver. You're like racing along the track, and your task is to check if you already have 3 power-ups at hand. If you have 3 power-ups already, then you can't really pick up the another power up, right? But if you do have less than 3 power ups, then hey, you are able to pick another power up and then add it to your inventory and then use it later on during the game. So one more thing that I would like to draw is like this essentially is a struct of itself. This struct is called item t, and it has only one field, which is the name of the or the character array or the string, the name of the power up itself. So just call it name or whatever, right? So our task at hand is very easy. So it's not like to me this question is almost there's not a lot of like logical thinking going on. If I'm being honest with you, this feels like more syntactual to me, if anything. So what we'll do is, does anyone have any questions for me? Like they got lost, like what we're trying to accomplish? Okay, that's perfect. Maybe I didn't see this. So now what we have to do is first thing I need to kind of check, like if I'm racing along the track, the first thing I need to check is, hey, do I have more than or equal to 3 power-ups? Do I have more than or equal to 3 power-ups? If that's the case, well, I can just return the zero, right? As in I was not able to pick the power up and just like move along. The opposite of that would be, well, hey, I had less than 3 power-ups. So then I'm able to pick a power up, add it to my inventory, and then move along. One thing that you kind of have to like keep in mind is this is kind of like a nested struct, right? Let's do this. So this is name, count, and this is item, right? And this is pointing to a struct. Could be a struct, could be an array of structs. I want you to think of this before we begin. Since I have a pointer, this has the ability to point to a struct or an array of struct or an array of structs, right? Why do you think that is, right? Does like anyone in the chat want to like take the what's the word? Why do you think like a pointer is able to either point to a struct or it can point to an array of structs? Why do you think that is? Like try to ask yourself that question. Okay, that's fine. That's fine. Since we know arrays are what? Arrays are a contiguous block of memory, right? They're next to each other. So essentially, these are my neighbors. These are my neighbors. So if I live at house A and house B is my neighbor, well, I already know I have to, where do I have to go, right? Just think of those in terms of like a real life scenario. Since I know, since arrays are contiguous block of memory, I already kind of know where my neighbor is, right? They're not like linked lists where somebody has to tell me the address before going there or something like that. So arrays are contiguous block of memory. That's why a pointer of item is able to point to either a struct of item itself or an array of items. So that's the whole idea. And then each item has a string, which is the name of the power up. So let's say we had two power ups initially. Now I picked up the new power up, I add it, and then I copy the string that is mentioned in the function. So to do this, you initially might think, hey, well, I have two blocks of memory with strings allocated already, and I've copied those values. Maybe what I need to do is I need to malloc a new array, right? Copy these values, and then add the third value here. You might think like, hey, I need to malloc or something, and then destroy this old memory. But the thing is, you can use something like reallocate, right? Where what you can do is, wait, is that really Dr. Ali? Okay, I got confused for a second. All right, so you can use something like reallocate in the sense where it would like create the new like fresh batch of memory for you. So like it will create this memory, copy these values for you, and then this you have this new block of memory where you want to insert the new item, right? And then it will like destroy this old memory for you automatically. So that's the whole idea. Did anyone get confused while I was like trying to explain? Yeah, if you have any questions, let me know. All good. Okay. Another thing that I wanted to say, like I will be coding on my laptop because the thing is like I'm kind of lazy. So yeah, I've been coding a lot. So before prior to like doing this Zoom review, I was able to like make three test cases for each problem that I was solving. So that way we know that the code works and yeah. So I'm just gonna switch over to my laptop and then we'll code it up. Let me switch over. All right. So let me try the screen share. All right. Hopefully you guys are able to see my screen. Let me know if you're not. All right, so we'll go to question number one. And then this is the function at hand I'm writing, right? So first thing, as I discussed in the, well, in the problem is like, first thing we need to check is, am I able to add a power up as I'm racing along the track, right? So I can just say if driver arrow item count is greater than or equal to 3, I'm not able to add this item to my inventory. So return the value of 0. So that's the first, like the base case, if you will. The opposite of that would be a, hey, I do have some space in my inventory, and then I'm able to like add some power ups in my inventory, right? So that's what I'm gonna do. So this is the part where I will be using realloc, and realloc automatically like creates the new batch of memory, copies the value over, and then destroys the old memory. So we say driver arrow items equals to realloc, right? And with realloc, you kind of have the function takes in two parameters. At any point, this is like kind of like a general advice as well, if you will. Like at any point you see a function that takes in two parameters, the first one is always the like the destination, and the second one is always the source. So that works for string copy as well, or string copy, and then other functions like string compare or whatever, but not really. So this is like generally how most languages work. If there's a comparator function, and you have like two parameters, it takes in two parameters. The first one is always the destination, and the second parameter is always the source. So now I'm calling the realloc function, and I'm telling like, hey, this is where I need to. So the first argument that I'm going to feed it would be where I want to allocate the memory at, right? So it'd be driver arrow items, right? Then that's the where I want to allocate the memory. Then I'm going to use a size of operator item t times driver arrow item count. Item, sorry, it should be in parentheses. Driver arrow item count plus one. All right. So now I've created this new fresh batch of memory, copied over the values, and destroyed the old memory where the old inventory essentially. Anyone have any questions for me so far? This is like, I think to me, I would say this is like a more uh, syntax heavy question rather than a logical heavy question. So that's why the second question that I will be covering in this video would be like more so on the logical part. So I just wanted to cover like a syntax question and a logical question. So once we have made this memory, now I have copied over the values, created the new memory. Now I want to insert the new power up item in my inventory. So I'm going to use the string copy function. Then again, as I said, string copy takes in two arguments. The first one is always going to be the destination, right? So I'm going to dereference driver arrow items. Since I'm dereferencing an array, I have to specify at which block of memory I want to insert the element at. So I'll be say driver arrow item count. Sorry, item count. I cannot type that. Item count dot item name. This is like the array itself, right? So if you can see, this is the array itself right here. So I'm dereferencing. So I have a pointer driver. I'm dereferencing this field here, and then since I'm at the object itself, I can use the dot operator. And the reason I'm not using count plus one is because arrays are zero-based index, right? So if I have initially, I had two items, and the third item, it would be at position number two, right? So that's why I'm not using item count plus one. And then what I want to copy, I just want to copy new item arrow item name, right? Once now I've copied over the values, now I want to increment the item count that I have in my inventory by one. So driver count, so it'd be driver arrow item count plus plus. Then we can just return the value of one as in we were successful in inserting a new element to our inventory essentially. So this question is kind of like, I'm not gonna lie, it is a syntax heavy question rather than like a logical question. I so yeah. Anyone have any questions for me? As in like you might have got confused, like, hey, why did you use the dot operator here, and why did you use the arrow operator here? Did anyone have any questions for me on that?
Yeah, I was confused about that too.
Okay, all right. So let me try running this code first, and I'll explain the diagram version of it. Okay, let's see. Let's see if it works or not. UCC1.c out as one. Okay, it works. Perfectly works. Okay, so test case one, there are no items, right? So I'm just inserting an item called red shell. So that's one case. Second test case would be I'm already at the maximum capacity. Uh, or well, sorry, I have two items in my power in my inventory, and I'm adding the third item. So that's case number two. And then the case number three would be, as you can see, it's failed because I already had three items in my inventory. So that's why I was not able to add in the value, right? So let's do this. Okay. So the reason for this is I'm gonna use like in terms of almost like Java terminology, if you will. Let me stop sharing my screen and switch over to my iPad. Okay, I don't know. Can you just see my screen, my iPad screen? So it's like, let's say I have this struct. This is name, right? This is what was it? Item count. Let's call it item count. And this is another, well, a struct. This is a struct itself, right? An array of structs. Let's say we have two values in the beginning, and this is just a string. This is also a string. So for this struct, I have well, I'm not at this struct, right? I have a pointer to the said struct, as in I have reference to this struct, which is called, let's call it driver, as in driver, right? So driver is a pointer of type this struct, which is pointing to this memory here, right? So I'm dereferencing the item itself. So I'm saying, hey, because I have an address, right? I'm not actually located at that position. So I'm gonna dereference the item. Then since item is an array, right? So I'm saying dereference the item. So what is item? Is item an array itself, right? So I'm gonna use this parentheses, whatever we call it, right? And I'm gonna say, since in this parentheses, I need to specify which position I am referring to, right? So let's say we're referring to position number two. So this is 0, 1, and this is the new block of memory we created. And essentially the string is empty. Like here's something, this string is empty. So at position number two, now I'm at position number two itself. I'm kind of at this position itself, right? So that's why I'm able to use the dot operator. So think of, like, ask yourself before writing the code, like, do I have the address, or am I at the current position itself? Do I have the reference to the object, or am I at the object itself? So in this scenario, you dereference the item, you specify at position number two, you're currently at that position. That's why you're able to use a dot operator, and then say like the string, right? And then copy over the values. Maybe I didn't do the best job at explaining that. Did that, I mean, who had a question, I guess. Did that clear it up? Clear it up? Sorry.
Yeah, a little bit. I kind of understand what you're doing with. Yeah.
Yeah. So like, again, this is like kind of, I'm not gonna blame you. This is kind of like a syntax heavy question. So yes, it looks something like this. So ask yourself, at what point do I have the address? Like, initially driver is just a pointer to this state structure, right? So I'm dereferencing the item itself, right? I'm dereferencing this field. This field is an array. So I'm going to specify the position that I'm referring to. I'm referring to this position. Now I'm currently at this object itself. So I'm able to use the dot operator. So that's like the
Oh,
whole, if that cleared up. Did that clear up?
yes, it did. Yeah, I know what you. I get it now.
Okay, perfect. That's good. That's good. All right. Okay. So that's question number one. It works perfectly fine. Any questions for me? No more questions? All right. I'm gonna pull up the second question. Give me 1 second. And I'll give you guys a minute or so to read it by yourself. And then, yeah. Okay. Let me pull up the question. Uh, question number two. Where's question number two, guys? I cannot see it. Oh, right here. Okay. So this is the question. I'm gonna give you guys like 2 minutes to read it on your, or like a minute or so to read it on your own, and then, yeah, we'll begin. All right, so I'm just not gonna. If you were able to understand the question, good. If you weren't able to understand the question, that's fine. I kind of like this question is kind of like more on the, it's heavy on the logical side of things rather than like being it like mostly syntax. So that's why I ended up picking this question. So it's called Pascal's triangle. The rule is pretty simple. Like you have a row array or whatever. Let's call it we have three. So this is let's call it row one, row two, row three, and then row four. Each row will have the same amount of columns. So for row number one, I will have one column. For row number two, I will have two columns. For row number three, well, I will have three columns. And then for row number four, I will have four columns. Uh, don't get confused. This is in uh, behind the scenes. This is like actually row zero, row one, and all that. But to make it like easier for you to like connect the dots, that's why I'm using row one and then row two and so forth. So don't get confused with why am I calling them row one and so forth. Okay. That being said, the rule of the Pascal triangle is the first column of each row and the last column of each row is set to be one. So this is one, 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 and this is one. This is like the rule of the Pascal triangles. And whatever elements that I was not able to feel, the elements within the middle are essentially just the summation of the last row, last row, column minus one. So this would be two. This would be the summation of this three. This would be the summation of this three. And now to make your life a little bit easier, I would like to show you guys a small visualization of this as well. So I'm going to share my screen on my laptop, desktop. I'm going to go on Google and then, so I'll do lead code Pascal triangle. Come on, Wi-Fi. All right. So this is like the visual representation of what a Pascal dragon should like to look like. So I'm going to give you guys like, let's do one more iteration of this. So hopefully that made sense. Like, so at the middle values that we weren't able to fill are just the summation of the last two upper values, as in the last row, column minus one, last row, and the same column. So that's like the whole idea of it. So did anyone have any questions for me with that? Like what we're trying to accomplish? So that's what we're gonna do eventually, right? So can I like was everyone able to understand conceptually what we're trying to do here? Or do you guys want me to like take some more time explaining uh the problem at hand? You can just speak up or you can type in chat. I understand the premise. Okay, that's good. This is again like this is like a good problem. This is like a good problem as in this like kind of like challenges you logically rather than just you knowing the syntax. So that's why I picked this problem. All right, so hopefully you understand it. The visual diagram. If you didn't understand my explanation, you can ask like Claude or something, or you can just reference to the lead code problem as well. That is a really good visualization. So now let's just begin writing the code. So this is the code we're interested in. Right. Okay. So the first thing is I will need to allocate memory for the rows, right? Which is passed to the function to be what? N. So I will have my int, let's call it int star star res equals to malloc size of int pointer times n, right? And the reason it's a int pointer is because we're trying to allocate a memory of integer pointers, and these integer pointers will in turn point to an array of integers. So that's why it's like a double array, if you will, or a nested array or a matrix, right? So once we have done that, now what we want to do is we want to loop through this each integer pointer array. So for int I equal to 0, I is smaller than n, I plus plus, right? And then for each block of memory, I want to allocate more memory of the size of Well, I plus one, right? So that's what I'm gonna do. So I'm gonna say res at I equals to malloc size of int size of int times I plus one. Anyone have any questions for me so far? Uh, so like I have created a memory for the rows, and now I'm like looping through on the rows, and then for each row, I'm creating the memory for the columns, which is said to be what? I plus one, right? Because initially I will start from zero, and then for row one, I have one column, row two, I have two columns, and so forth. Now I have created my memory part. Now I need to follow the rules of the Pascal triangles. So the rules of the Pascal triangles is what? The first column and the last column for each row is marked as one. So let's just do that. So res at I at zero. So res at I at zero. So I'm saying I'm referencing the first column in the row equals to one, and then res at I. Oh my god, I cannot type today. At I equals to one. All right, so this is the part where I'm marking the column. So this is the part where we are marking the first and last calls as one, right? Now now I need to loop through my inner values that I wasn't able to mark, right? Okay, why is it telling me? Okay, yeah, there you go. For int j equals to, okay, you guys tell me this. I'm gonna kind of leave something like open to you guys, j plus plus. So where should you guys think my J loop should begin from? Should it begin from zero? Should it begin from one? Should it begin from two? What do you guys think? Just throw in some random numbers. Let's see if anything sticks. Because did I again sorry? It should begin from one, right? Because the exactly perfect, exactly. That means you guys are able to make the connection. So it should start from one because the zeroth index or well the zeroth column was already filled by one, right? So that's exactly what we're doing. It will start from one and it will go till I, because then this ensures that I'm like just looping till the second last column, right? Once we have done that, now this is the summation part where I need to fill in the value. So res at I at j equals to res of I minus one, as in the previous row, previous column, plus res at I j. Let me just do this. I don't know why Vim is messing up for me today. Yeah, I don't know what's going on with I think I need to change my config file. Something's going wrong. Okay, so this is the part that I have done. So this is the left vertical diag. This is like the left vertical diag, and this is the row just above. So once I've filled it, I can just return the try array and it should in theory work. Return the res array and it should work. Now try let's running it. Maybe it doesn't work. Let's see. So, okay, anyone have any questions for me? This is like on the logical heavy side of things. So I might, okay, I'll draw a diagram of like what I was trying to do. So let's see, compile one, 2.c out as two, then two. Okay, yeah, it works. So now let me switch over to my iPad for a second and then try to explain it one more time. So not everyone gets lost. Again, nothing is going my way today. What's going on? Okay, let's do this. Okay, guys able to see my iPad screen? Okay. So now I have something like this for rows. I have these rows. Let's do row one, row two, row three, row four. Okay, this row will have one column. This row will have two columns. This row will have three columns. This row will have four columns. And the rule of the Pascal triangle is the first and the last columns are filled with one. So one, 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 and one. And these middle values are essentially just the summation of the row above and the same column, the row above in the vertical diag, in the left vertical diag. So this is what? I minus one, sorry. So for this position, it would be, to refer to this position, I am saying I minus one, j minus one. This is how you get the left vertical diag. Plus I minus one and j. So for this position, this is the value. Okay. Now, again, for this column, it is essentially just the summation of the column right above, which would be this one, and the column in my left vertical diag, which would be 3. Again, for this position, this is the summation of this plus the left vertical diag and 3. So this is essentially what a Pascal triangle is. Again, I can explain it to you, but you might understand it now, but you need to code it up, since the window is short, you have your exam in the next, like, what, you have like, what, 10 hours, 20, like something like that. So try to code as much as possible, so like the things that like they stay in your head. With that being said, anyone have any questions for me? Well, make sure to ask any questions. There's like, this is a judgment free zone. uh yeah, any questions for me? Good. All right. Okay, now again, I'm going to switch over to the next question, give you guys a couple of minutes to read them, and then try to explain it myself. Question number 3. Oh, actually, question number 3 is the answer. I don't know what happened. Okay, question number 3 is this. Let me just share my screen now. Question number 3 is remove duplicates from a linked list. This is the question that we're trying to solve. I'll give you guys a minute. This is a short question, so yeah. Okay, this is a short question, so I'm not gonna give you guys too much time because yeah, I'm just trying to like mimic the environment for your test, if you will. Okay, so let's take this example or this example linked list. Our task at hand is to, you're given this linked list. You just need to remove the like the duplicate values in this linked list, right? So this is the head of the linked list, and this is where it ends, right? This is the null where it ends. So what we need to do is we'll have our temp variable at the same position, and we need to, couple of things we need to check is we need to check if the next place is not null already. Because if it's null, then we're dereferencing a null pointer. What does dereferencing a null pointer do? It causes a segmentation fault, right? So you cannot dereference a null pointer. So you have to first, before even going, you need to check if the next value exists or not, right? So you need to say while t arrow next not null. So this is the thing that you need to check first, right? If it's not null, then that means there's a value for me to compare. I will check if t arrow val equals to t arrow next arrow val. If this is the case, then I know for a fact, well, these two values are the same. I need to remove this value from my linked list, right? So if t arrow val equals to t arrow next arrow val, I need to get rid of it. So what I will do is I will make the connection. This is the important part of like figuring out linked list. So instead of this pointing to this, I will say, hey, point to this. So I no longer have a connection here, right? then I will keep my temp variable to be at the same place. I'm not going to move my temp variable until I know for a fact that the next value is not a duplicate. And the reason for this is, let's say, instead of this being 2, this was 1 again, right? If I move this position, if I move my temp variable to be here, well, it would dereference the next pointer at which, well, 1 does not equals to 3, right? So it will not remove this value, move t here, right? So now, as you can see, is I have 2 of the same values. So that's why I'm not going to move my temp variable by 1 position. And the reason for that is I am only going to move it when I am sure the next value is not a duplicate. So that's the whole idea. Anyone have any questions for me? The code part of it is like pretty simple. Once I code it up, it will make a lot more sense. So with that being said, anyone, I'm kind of like rushing. I feel like. Are you guys fine with my pace? Okay, hopefully everything is fine. Hopefully I'm not rushing too much. Uh, but we're almost an hour in already. Okay, so anyone have any questions? Like they were not able to understand it conceptually or anything? Hopefully not. Okay, now I'm just gonna code it up. It's pretty simple. It's not like, can we see answer mayhaps for the problem that I just covered? Okay, all right. So now the problem I'm gonna be covering is Vim what? It's called 3, right? This is the code I'm interested in writing. Can you guys share us? Can you guys see us? Yeah. Okay. So what is our base case? The base case would be if the root is null. If my root is null, then there is no linked list, right? If the root is null, then return null back to the function as in, hey, there's not even a linked list. So what's the point in even doing the whole iterations on now, right? The second part is I have my iterative variable. So it would be list node, and this is the structure for it, as you can see up here. This is the structure for it. 5. List node star, let's call it temp, or let's call it cur equals to the same place as the root. Now I say while cur does not equals to null and cur arrow next not equals to null. I wanna like I wanna check if the next value is a duplicate or not, right? So for that's the first part I'm gonna do. If cur arrow, cur arrow well equals to cur arrow next arrow val, I know this is a duplicate, so I'm gonna kind of like skip this node. So I'm gonna say cur arrow next instead of pointing to the next node in my linked list, which I know to be a duplicate now. It points to the next node. So cur next arrow next. And the reason again in this if block I'm not doing in this if block the reason I'm not doing this cur equals to cur arrow next is because I want to make sure that the next value if I were to like jump to the next like the next location, if I were to skip a value and jump to the next location, that would I would maybe that is a duplicate as well, right? So that's why I'm not doing this part here. So this is why I'm going to write a comment. Not doing this here. Okay. Else, the opposite of that would be what? That I know for a fact that the next value is not a duplicate. If I know that the next value is not a duplicate, just move over, right? So cur equals to cur arrow next. And at the very end, we can just return root back to the function. All right. Anyone have any questions for me?
I do. Wouldn't that make like a dangling pointer? Like just
Dangling pointer
yeah, wouldn't that create a dangling pointer?
for which line?
Because there's nothing pointing to the old current next.
Say that again, sorry, I can hear you.
Like yeah, wouldn't there be a memory leak because current next now
Oh, okay. Okay. I see now. Okay, okay. So in this question, that the premise is given to you that the memory will be freed within the main later on. So you don't need to free the memory. Is that what you were asking?
okay.
Yeah.
Yeah.
So in the Yeah, okay. Yeah, okay. Sorry, I forgot to tell you guys. Because the thing is, I'm used to Java, and Java like memory is automatically freed, so I didn't. Thank you for bringing it. That's a good point. So in the question, you just have to make the connection, right? What if there are four duplicates? But then there's no list. No, if there are four, okay. Now you guys are bringing. Okay, let me run the code, show you guys, and the first thing I will cover is not freeing the memory, and then the second thing, you bring up a good point. There are four duplicates, or the list is all duplicates. Actually, you will see with one of the examples that I'm going to cover, one of the test cases I wrote. I'll show you guys. Okay, so it was GCC. This is question number three already. 3.c out as three. Okay, look at number one. This is 1, 1, 2, 2, 3. At the end, it is 1, 2, 3, right? This list has no duplicates, so it's the same list. Now, the question that you had, Jeremy, is like, what if there are four duplicates? 7, 7, 7. Then there's only one element left, right? Because what would happen is I am currently here. I start from here, right? Then I check the next value is a duplicate. 7 points to this 7 now, right? This my current variable is still at position this, right? Now this variable is pointing to this variable, right? Now I check if the 7 also again is 7, right? So again, instead of pointing my this here to this points to 7 again. Now I only have two elements in my linked list. Again, I check if 7 arrow next is not null, it is not null, and they're the same value. So instead of pointing to this, it points to null. Did that make sense, Jeremy? That's a good question. Do you want me to draw a diagram of it? If you guys want me to, I have time, honestly. Like I have time. I want you guys to understand it. Okay, I'll draw a diagram. That's good. All right. So the first thing, I don't know what your name was that you said about the dangling pointer, but yeah, you're given in the function. The premise of the function is that you don't have to free any memory. This memory is freed somewhere within the main. You don't have to worry about the freeing the memory. Just forget about it for a second. Okay. Okay. Now let me share my screen. All right. So now let's take the example of 7, 7, 7, 1, 2, 3, 7. And now let's do a different color so it's easier for you to track. Now let's use color green. Okay. My head is here, right? My head is here, and I make a new variable called, let's call it car. Let's call it C. Okay. C arrow next is pointing to what? 7, right? This is a duplicate. This is a duplicate. Instead of pointing to here, now it points to here. And this is free. Just for now, just think in your head like this is automatically free. You don't have to worry about it. Okay. This part makes sense so far. At this position, if there are matching values, I told you guys in the beginning, right? I'm not moving my C variable while to the next node in the linked list because of this exact problem. If I were to move my C variable here, then look, this is the duplicate, right? I will get rid of it and I'll make the connection, but the list will be what? 7 and 7. So this is the exact reason if the values match, I'm not going to the next element over because I want ensure that the next, because I don't know what the next to next value is, right? So if the next to next value is again a duplicate, well, I kind of want to stay at the same position and then make the connection to next to next to next. So let me get rid of this for a second. Okay, so now we figured out, hey, that this is the next value is a duplicate. So I make the connection to be here. My C tracker, again, notice my C tracker, my current tracker is here. I'm not moving my tracker here. We get rid of this, right? Now we again ask ourselves, is the next value null or not? Well, it's not null. And it is the same value that I am currently at, right? So instead of pointing to this, point to this. So instead of pointing to this, it points to all the way over here, and this value gets rid of it. Again, I'm not moving my C tracker for this exact reason, because we don't know what the next value is. The next value might be a duplicate, might not be a duplicate. So we explicitly move our C tracker only when I have verified that the next value is not a duplicate, right? Again, this is a duplicate value. Instead of pointing to here, I'm going to point to null and get rid of this. And at the end, my list would be just this. Did that clear it up a little bit more? I think two people had questions similar to that. Uh, uh, Yeah. Do you like did it clear it up? I think two people had. Jeremy had the same question, and then he would. How would we know when we? How would? Okay, hold on. How would we know when we wouldn't be expected to free a node in a linked list in the question? Okay, if it's not said, if it's not told you, like, hey, in the question, if it's not mentioned to free the memory or anything, you can assume that you don't have to free any memory. But if in the question is explicitly mentioned, hey, make sure that you're not creating any dangling pointers or any memory leaks, then you have to free it because this is question is more like a logical question rather than it being a syntax question because in high level languages you don't have to worry about freeing memory. So like in Python, you some of you might have taken Python at UCF or object oriented programming. You don't have to free the memory, right? It is automatically free. So that's the whole idea. With that being said, who were the people who had questions from Christine, Jessica, and then okay, a lot of people had. Did I clear your doubts, or do you guys have more questions for me? It's fine to ask me questions. That's fine. That's what I'm here for. This is like you have your exam tomorrow. You if you're not asking me questions because you're scared that I'm people are gonna judge you, then forget about it. You should worry about your exam. Don't worry about people. Anyone understand? Can I move on? All right. Okay. The third question is the tracing question. Let me share my screen. I'll give you guys a couple of minutes to read it, and then we'll begin. I mean, the fourth question. Sorry, the fourth and fifth question are conceptual questions. This I don't know what happened to my app. It's not letting me use the eraser. Give me 1 second, guys. There we go. I think my iPad is like overheating or something. If you have time, can we go? Okay, if I have time, I'll go. Uh, okay, if I have time, I'll go over them. But the thing is, okay, I'll go over it if I have the time. It's like a more, but the way I'm gonna explain it is gonna be like a little. Okay, I'll explain it, but the way I explain it might be a little. It might confuse you guys. So that's the thing. Okay, I don't want to cover it. I'll be honest with you. I won't cover it. And the reason for this is because the way I understand it and the way it's taught in class is different. So if you don't understand it, then watch the lecture. Because I'm not better than Dr. Rahman or Dr. Ali. They're my superior. I mean, obviously I learn from them. I go to their classes, so and they're better. So just go to their lecture or just watch the recording. Okay, what am I doing here? Showing you the question. Okay, I actually disconnected. Okay, sorry guys. Sorry for the all the issues. Okay, let me show my screen. Share screen. This is the question. Give you guys a couple of minutes to read it, and then yeah. Can you zoom? Yes, sorry. Is that better? about this? Is this better? Okay, okay, this is fine. This is a question that should not take you long. I'm gonna just cover it a bit more. Okay, so let's just draw the link. This I'm gonna switch over to this like this in portrait mode or whatever. Okay, so I'm just gonna redraw the linked list as a rough work for myself. Then no. Okay, another thing that I would like, another small tip, I guess, like make sure you always have this null here. Like in this question, look, they don't have this like right here, right? So yeah, make sure you do this so it's easier for it becomes even easier for you to track. All right, so now let's use different color. Let's use red. Okay, first let's just go line by line, right? So let's this line, right? We have a temp variable that's initially initialized to be the same place as had. We have another variable, let's call it T2, which is again the same place as we had, right? And then we have our variable int A, which is essentially some garbage or whatever. So now we have our while loop. It says while temp arrow next PTR does not equals to null, we're gonna do something within this while loop, right? So I can check to myself, does 5 arrow next, which is 2, is it null? Well, it's not null, it's like a legit value. So I'm able to do something, right? So now A catches the value of temp arrow data, which is what? 5, right? Then temp arrow data catches the value of temp 2 arrow data. Oh, sorry, actually I made a mistake, sorry. So this is temp here and this is T2 here. Okay, now temp, instead of being 5, it now has the value of 2, right? And then T2 catches the value of 5. Okay, now this is a recurring thing that is going to happen. So what does this ask yourself in the exam? If you see something like a while loop and this thing is happening again and again, in the first iteration, it's evident that the swapping logic is happening. So just write the comment swap. So that way you already know, you don't have to like keep track of it one by one. So in the exam, you're like save some time, right? So I know for a fact that these 3 lines, they swap the value between the pointer t and the pointer 2. So I know that, so that's what I'm gonna do, right? Again, temp equals to temp arrow next. So temp, instead of like at this position, now it goes to this position, right? Now again, in the if statement, if temp arrow next is not null, I know temp arrow next, which is this, is not null. Temp goes to here, and then temp arrow 2 uh, goes to temp arrow next, right? Which is this. Did that make sense? Like why temp 2 instead of, so look, temp 2 was here, right? In this line, my temp variable instead from here came to here, right? In this if statement, I'm checking if temp arrow next, which is this, is it null? It's not null. Then temp goes to this position. Temp again does one more hop. Then we said temp 2 equals to temp arrow next. Temp arrow next is what? 8, right? So temp 2 goes here, right? So this is the position I'm at. Now you circle back to the while loop. You ask yourself, does temp arrow next equals to null, right? It's temp arrow next, it's not null. It's like pointing to a legit value, which is of 8. So again, I know for a fact, hey, this is a swap logic. So instead of like redoing it in your head again and again, I know for a fact from the first iteration, it was pretty evident to me that it is a swap logic. So I'm just going to swap the values over. So 8, 1. Again, now I'm going to repeat this process. Temp equals to temp arrow next, right? So temp comes here. In this if statement, I'm asking myself if temp arrow next, which is 7, is it null or not? Well, it's not null. So what we'll do is we'll move temp to be here, right? And then temp 2 goes to temp arrow next, which is here. Again, I will circle back to my while loop. And at this position, this statement is indeed true, right? So I'm going to stop. So what would the final answer would be? Just 2, 5, 8, 1, and then 7. So that's how you track it. Again, this is like a little bit easier for me because I'm doing it on my iPad and I have like different color to choose from. But in the exam, you will only have the pencil, right? So it might be a little harder. So that's why it's to me right now it might look easy for you guys because I was able to show you with different tracker, different color. But in the exam, maybe this is a little bit tougher for you guys to crack because you don't have different colors, so you only have one color. So okay. With that being said, any questions for me? This was a pretty simple question, but I wanted to show you because in the exam, okay, another one thing I want to tell you guys. Most likely, you will get a coding problem for linked list, and you will get a tracing problem for linked list. That is how it was last semester. That is how it was when I took the class personally. I got a coding problem and I got a tracing problem. One more thing that I want to show you guys, not will tell you guys, is make sure that you're practicing. Because what is like most of the questions you see in the FE in your classes is singly linked list over and over again. That's exactly what happened to me. I practiced a lot of singly linked list, and I maybe did like a couple of questions for doubly linked list. And on my midterm, I had a coding problem for a doubly linked list, and I fumbled. I fumbled because I didn't practice it. So make sure to like practice everything because they might give you a coding problem for doubly linked list or a tracing problem from doubly linked list. So don't leave any stones unturned, as they say. So with that being said, any questions for me? Uh, yeah. Okay, if no questions, we move on to the question number 5, which is again not that bad. Question number 5 is this. Can we see the code? Okay, I can show you guys. Okay, if I have some time. Wait, why did somebody say the skull emoji? What happened? Okay, I'll show you guys the coding problem. Like I'll show you guys the move head near tail or something. Okay, let me show you guys the. Oh, okay. All right, now we cover this problem. This is super important. Okay, now this is I'm gonna give you some tips. There's no reading here. This is like straightforward. First of all, can you guys see my screen clearly? Is it like too small? Is it too big? Let's make it a little bit bigger. You guys can see first is you guys can see the screen fine? Okay. So in your midterm, I can almost guarantee you like 90% chance you will get infix to postfix. And this is free points. This is like free points. This is if you're someone who's struggling, who has a struggle with coding, someone who's like has a struggle with like coming up with the problem solving skills building that. This is your just grab these points. This is like your gold mine. You should not, this is like free 10 points, grab them, right? And just move on. So with that one, make this is gonna be in your midterm 100, like almost 100%, like some variation of this, like different variables or not. Okay, with that being said, one thing that I've noticed last semester when I was TAing and this semester too, is people always get confused with this part. Where does it stop? Where does it stop? Where does it stop here? Does it stop here? They get confused with, hey, till which part I'm tracking, right? Easiest solution is this. Easiest solution I'll show you. Come on, man. All right. So the easiest solution is you see this problem? Draw a line from the middle. Draw a line from the middle. Draw a line from the middle. So now you know where to stop. Because I know people get confused because visually, some people have trouble like, visualizing stuff, and that's fine. So this is your way to like the first thing that when you see this problem, draw this line so you know up until which point I'm tracking the problem to. Okay. All right. Another tip I'm gonna give you guys is always do the until you reach this point, always do the work on the side. Look, they have given you so much space. Always do the work on the side because sometimes you might forget to use the eraser on your exam. So this is your rough side. This is your rough side. This is where you do the rough work. Okay, that's another tip. So tip number 1, draw this line always. And tip number 2 is do the rough work on the side. This is when I took this class, Dr. Ahmed told me this, and I think this is really good advice. So okay, now we just solve this question is very easy. Okay, no problem. So the first thing, anytime I see a variable, it could be they could give you like letters, they could give you symbols, they could give you something else. So anytime you see a variable, it goes to my expression. So I see 7 goes here. Now I see a multiple sign, it goes here. Now I see an opening parentheses. Opening parentheses will always go to my stack. If closing parentheses never goes to the stack, right? Closing parentheses will never go to the stack. Remember that. So an opening parentheses goes to my stack. Then I'm at, okay, you know what you can do? Again, I forgot to mention. In the exam, you can like cross them out. Like, hey, I saw 7, I saw this. And now I'm at 3, I cross it out, right? Now I see plus sign. Now, at any time your stack is not empty, your stack is, so in this case, my stack is not empty, right? Now I want to append the sign of plus. So whenever I'm appending a symbol, I check the last value in my stack. The last value in my stack has to be of a smaller precedence, right? But in this case, the last value added to my stack is an opening parentheses, and an opening parentheses will only get popped when I see my first closing parentheses, right? So 7, 3 plus goes here, and the last value is opening parentheses, so I have nothing to compare for, right? So it just goes here. Then I'm just gonna cancel it. Then I see a 9, I push it to my expression. Now see here, now I see my closing parentheses, right? So closing parentheses I will keep popping the values up until my first opening parentheses. So I'll pop this, pop this, pop this, and then my plus goes here. Parentheses will never go to your expression. I've seen a couple of students do this mistake that they pushing the parentheses in the expression. The parentheses will never go in the expression. So make sure of that. Now I see a negative sign. A negative sign it has a smaller precedence than a multiply sign, right? From the your PEDMAS rule, or what you call it, PEDMAS. So it just goes through my stack. Now I'm done. I'm for sure. I'm gonna cancel this out too, right? I am sure that I have stopped now. Now I'm gonna write my answer here, right? So this is the space on the side is always your rough work. Don't do it on the stack, because if you do it on the stack, then it becomes actually it becomes harder for you to track, and then it becomes harder for the person who's gonna grade your exam to track. So you want to eliminate as much as bias as possible for the grader, right? So that's why. Okay. Now I am for certain again. Now I'm gonna move on. First, I'm just gonna copy over the values on the side, right? Then I'm gonna start my 4, cancel it out, push it to my here. Now I see a division sign. A division sign has a bigger priority, or like bigger precedence than the negative sign, right? So I cancel this out, it goes here. A division sign has the same precedence as the multiply sign. So I cancel it out, it goes here. Now my stack is this. My stack is just this. Now I see a 6, I cancel from here, I put it here. Now I see a plus. Well, a plus sign, again, has a lower precedence, so it just goes to my stack, right? Cancel it out. Now I see an opening, goes here, 8, goes here, and then time sign. Since the last value is an open parenthesis, there's no like comparator for me, right? So I'm just cancel it out. 2 goes here. Minus, again, is of a smaller precedence, so this got canceled out. This goes here, and now my minus is here. Cancel it out. Now again, I'm in the opening parentheses, put it here. Now I'm at a 5. So this is at the end, this should be my stack. Is this correct? Or I think I messed up somewhere. Can somebody check for me in the answer key if I messed up or not? I think I messed up somewhere. Can somebody check real quick? Okay, let's see. Where I messed up. UCS. Okay, yeah, I messed up. I made a mistake somewhere. This should be not this. It should be, the stack should be plus this minus this. Okay, like look, I've solved these types of questions like maybe 20 times now, and I still make a mistake somewhere. So it would be, let's copy over 7, 3, 9 plus multiply 4, 6 division minus 8, 2 multiply 5. Okay, now I'm just gonna copy over the values. And you know what? The another thing is, before starting this review, I solved this problem by myself, so I'm of certain that I didn't like lose my skill, and I was able to solve it within the first try. And now look, when I'm in front of you guys, I'm not able to solve it. So look at the irony, huh? So another thing, that the key takeaway from this, I guess, is like you might mess up in the exam. So be careful, be careful. All right. So now I'm at a plus sign, goes to my stack, cancel it out. I see a 7, just goes to my stack. Now I see my closing parentheses. I get these values, cancel it out. And again, I see my closing parentheses, get all these values, Cancel it out. Now I see a division. A division just goes to my side because it is of a higher precedence than my plus sign, right? Division 3 minus pop these. So division plus, now my stack just becomes minus 9 multiply 4. And this is where I stop. Now again, this is where you have to keep tracking in your stack, right? But you're not done with your expression. So just copy the values over on the side, right? And then plus is of a smaller precedence than these two values. So pop these two values, minus, and then 6. And then there's a remaining plus, so add it here. So that's how you, a couple of my 2 cents on the whole issue. Uh, Again, I've solved this question. I like when I was practicing. Well, I took the class a while ago. I took the class almost like a year and a half ago. Uh, but I still messed up, right? So yeah, make sure to practice these as much as possible because this is almost like a guarantee that this will be on your exam. So yeah, any questions for me? Almost done. We have a lot of people. We have 42 people. Okay. Yeah, it is not that lower variable pops the higher variable indeed. So A is wrong. Yeah, maybe I made a mistake somewhere. Sorry, guys. Yeah. You're right. It should be this. Sorry. Okay, that means that is good news. If you guys corrected me, that is good news. That means you're ready for the final. I mean, not the final, the midterm. Doesn't it say the notes is current over? Okay. That is good. If you're correcting me, pat yourself in the back. You're prepared. All right. Any questions for me? We did say that no, we are done for. No. I believe in you guys. I believe in you guys. Cooked? No. Not cooked. Not cooked. Not cooked. You gotta uncook yourself. Oh, obviously, yeah. Okay. Okay. The problem is, I'll tell you what the problem is. If you say I aim for 100, you get what are you sending in this? Okay, if you aim for 100, you get a oh my bro, this chat is crazy, bro. Okay, if you aim for 100, you get an 80. If you aim for 120, then you get 100. So always aim for 120. You okay? I'm not looking at the chat. Hold on, I gotta upload this on YouTube, guys. Come on. All right. Now to show you guys question number 6. Let's lock in. This is the last question. That's the last question. Lock in, lock in. Last question. Yeah, lock in. All right. Let me just share my screen and just give you guys a couple of minutes to read it, and then we'll. This question is pretty simple, honestly. This question is not. I just wanted to cover this question because I want you guys to have like a coding problem for Q. But this question is pretty simple. There's nothing too crazy. Okay, I'll just hold it. I'll just cover this question. It's pretty simple. It's not nothing too crazy. The whole premise of it's like a bunch of jargon, but like the premise of the question is essentially, uh, are you guys hearing like double voices by any chance or something? Because I think my AirPods just died. Uh, my voice is normal. Can you guys hear me? Okay, see. Okay. Yeah, my AirPods just died, so I'm like worried. Okay. Time to lock in. All right, lock in. All right, so, bro, listen. Okay, let me cover this question and then we'll meme around. All right. Okay, so the problem is at hand is pretty simple. You're given a linked list implementation of a queue data structure. In a queue, what is a queue? First in, first out, right? Hello? Yeah, I think my iPad is overheating too. A queue is a first in, first out data structure. So that's essentially what we're doing. We're just adding the value to the first and then we're dequeuing the value. So this is just a uh, we're just designing a queue essentially and we adding to the front. Instead of adding to the rear, we're adding to the front. Because in a queue, what is it? A queue data structure, let's say you're in a gas station line, right? In a gas station line, you can only, if they're like, let's say this is a counter for the gas station, you're here, there are two customers in front of you. If you go in the front, then these all people are going to be mad, right? So that is why in a queue, you always go to the back of the queue, right? That's it. But essentially in this one, we're doing the opposite. We're actually trying to append to the very first. That's just the question. It's just trying to test your problem solving skill. This is not the real life implementation of the queue data structure, but it's just trying to test your knowledge from a different point of view, if you will. So task is pretty simple. Let's say you have this queue, something like this, implemented with a linked list. Your front tracker is here. Let's call it F, and your back tracker is also here. What you want to do is you want to make a new node. Let's say you want to make a new node. This new node will point to this position and then the front tracker will come here. So this is how you make the connection. So first, create node, create the node. Second, make sure that the created node is pointing to the front. Then third, the front points to the new node. So let's do this. The new points to the front and then the front points to the new node. So that's essentially the whole gist of the problem. And I'll code it up. It's pretty simple, honestly. If you know how if you know how to code up the normal queue with a linked list implementation, this should be like ABC to you guys, honestly. But let's still code it up because why not? Let's do this. Control L. All right. What's the question called? Vim C. All right. So this is the question I'm worried about. Line number 26 down. Okay. So the first thing is, as I told you in the diagram, is like first thing is you create a node. So the good thing is like they're given us the function already, so we don't even have to like malloc or anything. So we just gonna call temp equals to make node, and then we copy over the value which was in this, right? Which was given in the function parameter. So we just copy over the value. Right. Now I need to check a couple of things. First thing I need to check is my queue empty or not? If the queue is empty already, then that is the only person within the queue, right? That is the only node within the queue. So I need to check if my dq arrow front equals to null. And why am I saying the front and not the back? Because if the front is null, then I know for a fact that there is no one in the queue, right? Because if I were to say the back is null, then there might be like some values in the front and the back like somehow got positioned to null. But if the front tracker, if the front pointer is to null, then I know for a fact that the queue is completely empty. So that you can also do this, okay? And my dq arrow back equals to null. If you're like if the front part didn't make sense to you, you can also write it like this is the same, essentially the same thing. But just to save some space, we just write it like this. If the front tracker is pointing to null, then I know for a fact I have nothing. I can just say that my dq arrow front equals to temp, and then my dq arrow back equals to temp. I think I made a small, okay, right? and then we can just return. As in this, since it's a what type function, the return is essentially like a break statement, essentially. So if the queue is empty, then create the node and then set the front and the back tracker to be at the same position because there's only one node. So the front and the rear tracker will be at the same position. The opposite of that would be what? Hey, I have something in my queue. If I have something in my queue, I have in the question it is mentioned to us that you need to append the values at the very front of the queue. That's just how it is. They're just trying to test it out, right? So we can just say temp, which is the variable I created, temp arrow next equals to my queue arrow front, right? So this is the part where I'm saying the new node in the linked list, the next pointer is pointing to the front of the linked list. Now we can just say my dq arrow front equals to temp. And then that's pretty much it. That's the whole code for it. Can you guys hear some screaming? I'm sorry for there's some screaming. I'm sorry. Okay, so now let's just try to make it 6.c out as cannot type. Okay, I made a mistake somewhere again. My q is dq. My dq. Okay, GCC 6.c out as 6, then 6. All right, so this is like essentially what it should look like. Okay, if the queue is empty, this is the first case. When the queue is empty, I'm only adding the value of 10. So the front is pointing to 10 and the back is also pointing to 10. Test 2 is, oh my God, I'm sorry if you guys can hear some like screaming, I apologize. And the test case number 2 is like the front is, we have some values 30, 20, 10. And the queue after appending these values would be 10, 20, and 30. And then the front would be at 10, the back would be at 30. Again, this is we're adding the value of 99. So it would be 99 would be front and then 42 would be at the front. So these essentially like how the function works. That being said, any questions from me? That is the whole, review. Can you show the code again for the problem that I just covered? Okay, so it'll be vim edit. So this is the code. Hey, could you guys hear the screaming? I'm sorry, I apologize. There was some like kids in the background. Got it, thanks.
Nah, you good. You good. It's not picking it up, bro. You good.
Oh, okay. That's good. Can you explain the permutation? Okay, man, the permutation is like I would highly suggest that you watch the lecture. I'll be very honest because if I explain it, I'm gonna explain it in a way that is. I have a quick question about number 5, the stack question. Okay, let me first answer the permutation part for Benjamin. If I covered it, the problem is I understand it using backtracking. So actually, when you learn permutations in CS1, you're kind of learning backtracking. But I learned it because I'm taking CS2 currently. So when I learned it in a way of like CS2, like making the choice, not making the choice. So if I don't want to like override your knowledge with my version, because then that might not be in the exam, right? So for permutations, remember what is the runtime? Exponential, right? It's actually 2 to the power of n, right? Because for each element, you kind of have a choice of either taking it or not taking it. So remember the runtime, then remember the runtime. That's the only thing you need to remember. And then yeah, so I would if you're not able to understand it, I would highly say that you rewatch the lecture because I don't think I'm gonna be able to do a better job than Dr. Ali or Dr. Rahman at explaining permutations. So yeah, job. Okay, so I'll be very honest. When I took the class, I did not have a question for Tower of Hanoi or permutations. The only question that I had was at the very end of the midterm, they asked me like, what is the runtime of Tower of Hanoi, which was 2 to the end. So I knew that. But last semester, they had a question for permutations. They had 2 coding problems for permutations. Matter of fact, the recursion section was the permutation section actually. So each topic that you have covered so far will have a section of its own, right? So DMA will have a section, linked list will have a section, recursion will have a section, queue stacks will have a section, the runtime analysis, the summations will have a section, and at the very end there will be some like MCQ type, like runtime guessing and all that kind of stuff. So last semester, in the recursion, they asked two questions for permutations. So I would say that you should brush up on it for sure. Can you cover a doubly or a circle linked list question if you have the time? Let me try to find it because the thing is, I need to find it first. Let's see. Because the thing is with doubly linked list and singly linked list, you don't see them too much in the real life as well. Yeah, actually, matter of fact, I'm gonna say something. You guys probably know this, but oh my God, I'm still recording the video. Hold on, let me not record the video first. Let me stop.